Okay, so polynomials of a higher degree. So polynomials of a higher degree. Polynomials look like they are curved functions, okay, and they kind of they go up and down. So, okay, be quiet. Quadratic functions are usually they make parabolas, right? Quadratic functions. Polynomials of a higher degree have curved shapes, okay? They usually go up and down. They do not, they could go up and down several times depending on the degree, so they can look like this or something. What they cannot look like is they don't have any breaks in them, so that like a piecewise function is not a polynomial function. This type of function where you have asymptotes, that is not a polynomial function. And functions where you have sharp points in them, like absolute value functions and stuff, those are not polynomial functions. So polynomial functions are smooth. They're smooth, meaning they don't have any sharp points, and they're continuous, okay? Meaning there's no breaks in them, okay? And they go up and down, okay? And we talked about what polynomial functions look like. They have they have a coefficient out in front, and like 3x to the fifth plus 4x squared minus 2x plus 6. That would be an example of a polynomial function. And these numbers, as we discussed, the exponents all have to be positive integers, except for the constant part. What's the exponent right here? It's like, so there's, like here, there's x to the 0, right? So you can't have x to the 0 as one of your exponents, but in general, the exponents have to be positive whole numbers, and then you have coefficients in front. Okay? So we're going to talk about polynomials of a higher degree in a minute, but the first thing that I'm going to talk about is y equals x cubed. Where did it go? How do I make it come back? There we go. There we go. Teacher notes, cubic functions. So a cubic function looks like f of x is equal to x cubed. That's the basic cubic function. Anyone know what that cubic function looks like? If I were to graph it, what, Colton?
Comes up from the bottom.
Very nice. Okay. Yeah, that one comes up. It comes up from the bottom, and it kind of goes through 0, 0, and it goes up like that. So that's the basic y equals x cubed. And if you don't remember, plug in some points, right? -1 cubed is -1, positive 2 cubed is 8, and so on and so forth. So it's negative, positive. We talk about the domain. So this is kind of an interesting one. Domain, what's the domain? Hey, quit bugging Nate over there, okay? Domain, what's the domain? What numbers can I plug in for x? Negative infinity to infinity is the domain. And likewise, the range is also negative infinity to infinity, right? Because it goes down forever and up forever, okay? It has an intercept at 0, 0. And what else? Domain, range, intercept. It is odd, right? Meaning that if I plug in negative x in here, I get out negative y, okay, over here. And it also means it has origin symmetry. Origin symmetry or rotational symmetry about the origin. In other words, if this has a point 8, comma 8 over here, then this point over here is going to be what? Negative 8, okay? So if I spin this point around, it's going to end up 180 degrees is going to end up over there, okay? So that's y equals x cubed. And they do talk about the like this being a parent function, and then you can do transformations just like you can with parabolas of y equals x cubed. So watch, look at this. Aren't I clever? I made this. Y equals x cubed. So what would y equals x cubed plus 1 look like compared to y equals, I should make this. What would y equals x cubed plus 1 look like? You know? That just moves it up to 0, 1. So instead of it intercepting there, it would be here and go like this. We call this, I don't know if we really need to know it right there, but where it changes from being, call this concave down to concave up, you call that a point of inflection. You'll learn more about that in calculus, but that point where it changes from curving down to curving up is called a point of inflection. Okay? What would y equals x plus 2 cubed minus 1 look like? I already grabbed that one. Let's just, so think about it just like you think about parabolas. Go ahead, Tyler.
Would it be shifted left 2 and down 1?
It would be shifted left 2 and down 1. So the only thing that would change would be shifted left 2 and down 1, and then you could just kind of sketch it in there. Y equals x cubed. You could find the intercept by plugging in 0. 0 in there gives me out 8 minus 1, right? Which makes my intercept what? Up here. 7, positive 7. So this point would be 0, 0, 7. That's not a very good graph of it, but the inflection point is actually right here where it changes shape. But I did a bad job, but you get the idea, right? Questions?
So that would be...
Why? So this would be this one. Because it shifted left 2, the inflection point is shifted left 2 and down 1. Right? What would, here's a trick, what would this next one look like? Sketch negative 2x cubed plus 3. So if I were to sketch that, what's that going to do to it, Kai?
What?
What's this going to do to it?
Move it up 3.
It's going to move that inflection point up 3, right? But what's this going to do to it? It's going to stretch it, and it's going to flip it the other direction. So the negative sign is going to flip it. So instead of coming down to up, it's going to come from up to down, and it's going to be stretched out more, like something like that. Okay? So this one, just so you know, that's various ways to transform what cubic functions are pretty much any function for that matter, right? So this is going to take this point, move it up 3, and then flip it and stretch it. Good enough? Good enough. Okay, so now we get into some stuff that probably you don't know about, which is called end behavior. Whoa. First, the degree of a oh, I'm not done yet. Whoops. Where's that? I'll get there. Don't worry. Now, bottom left. The degree of a polynomial is the degree of its highest degree term. Okay? So just so you know that, if you have something like this, x to the 5th minus 4x squared cubed squared plus 2x, f of x equals, then this is degree what? This is degree 5. And we'll learn something about the degree in a minute. Also, if I have several things being multiplied by x squared plus 3 times x plus 2 squared, who can tell me what the degree of that would be? It would be to the 4th, okay? Because, so this is 4th degree, 4th degree, because if I took this and I FOILed it out, you don't actually have to FOIL it out, right? I would have an x squared here, and an x squared times an x squared. My highest degree term is going to be an x to the 4th. You understand that? No? Looking kind of confused there, Alex.
I get it.
You get it? Okay. So this is fourth degree. Cubic is cubic degree, and so on and so forth. Okay? Questions about that degree? All right. Then we talk about the end behavior. Okay? And that's, we're not talking about a football game here. They're talking about some of those end behavior. That's not a good graph. And the behavior is, what is my end behavior is a way of sketching. It gives you a method for sketching the end parts of a polynomial function. So, for instance, if I want to know what is x to the fifth doing down this way and up this way, or what is a polynomial of degree 6 doing at its endpoint, okay? And that's what end behavior is. And so I have some notes. If the leading coefficient is odd, okay, so there's if leading coefficient is positive, if leading coefficient is positive, and function is of an odd degree, that doesn't spell degree, does it? Degree. Then, okay, your end behavior looks like this. So for instance, if I have something like y equals x to the fifth minus 4x to the fourth plus, it doesn't matter what comes after, x plus 6, I'll put a 3 in front of here just to make it interesting, okay? This is a case in which the lead coefficient, that's called the lead coefficient, is positive, and the function is odd, okay? So the degree of this is fifth. Then it looks just like a cubic function on the end. So then the end behavior looks like this over here and like this over here, okay? I don't know what it does in the middle, but I do know that to the left it looks like this, and to the right it looks like this. Okay? So you should be writing some of these down, at least paying attention to them. Some of them are kind of common sense. I'm just going to change some of these words. Okay? Got that one? Okay? So what if the lead coefficient is negative? What if I change that to negative? Negative, and the function is of an odd degree. So what if I put a negative sign in front of the 3? What's going to happen?
It goes down.
Yeah, it starts from the up, and it goes from the down. So if I throw a negative in front of there, it's going to start from this side, okay, and it's going to end down this way, okay? So that's what that one looks like. You get that? Okay. Can I change some things on here? What if the lead coefficient is positive? I'm going to do more colors. Okay. Lead coefficient is positive, and the function is of an even degree. Okay. What's going to happen in that case? What do you think? It's going to be up, up. Just like y. So, for instance, if I were to change this, and make this 3x to the 6th, okay, then it's going to start up, and it's going to end up. At the very end. I don't know what it's doing in here, okay, but I need to know if I zoom down on it, it would look kind of like a parabola from very, very far away. Yeah? Good? Okay? And the last one is, what if I change this to negative right here, okay? So what if I change this to negative n of an even degree? Then what? Common sense. Yeah, then they both face downward, right? So if I do that, then if it's negative, an even degree, as in negative 3x to the 6th minus 4x to the 4th minus x, and it's going to start down, and it's going to end down, okay? Because what happens is, as this number gets really, 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 really big, okay, all of this other stuff just kind of becomes unimportant, okay? And so the 3x to the 6th way outweighs everything else, okay? And if this negative sign is going to make everything negative. So what happens is, the leading term is the thing that kind of determines the end weight. All right? Got it? Okay. Do you want to hear another story now? No, I don't have time. No. Ella doesn't want to hear another story. Okay. So, sorry. We can't. Okay? The degree, I already talked about this. The degree of a polynomial is that of a polynomial of degree n has at most n real zeros. Okay? So this is important. If I have a 5th degree polynomial, this one we know is going to start down and go up, and the most time it can cross that axis is 1, 2, 3, 4, 5. 5th degree. Is that right? 1, 2, yep. So a polynomial of degree n has at most n real zeros. So the most places that this thing can cross the x-axis is 5. Could it have less than 5? Yeah, because it could kind of just bounce here, right, and take off. Or it could go like this. It could go through once, and it could bounce around and go up like that, and only hit it once. But the most it could have is 1, 2, 3, 4, 5. A polynomial of degree n has at most n minus 1 relative extrema, maximums or minimums. Okay? So looking at this picture, look here. 1 maximum, 1 minimum. 1 maximum, that's called a relative extrema, where it changes from going downhill to going uphill. Okay? See how it has 4 relative extrema right there? That's the most you could have, is 1 less than the number of degrees. And this becomes important when you're looking for extrema in calculus, because you have to know, where does the maximum occur? Well, I could have 4 places where the max. Whoops! I just threw another one by mistake. Okay? But at most 4. It can have less. But can I move on? Okay. What's next? Real zeros of a polynomial function. Okay? So if f is a polynomial function, a is a real number, then the following statements are equivalent. X equals a is the zero of the function f. X equals a. I think that should say if. I think it should say if. I'm not sure. This one's kind of. If x equals a is the zero of the function f. X equals a is a solution to the polynomial f of x.
On the top. It says if this is
Oh. X equals a is a 0. Okay? X minus a is a factor, and a comma 0 is an x-intercept. So when they say find the factor, find the solution, find the 0, find the x-intercept, you're really answering the same question over and over. It's 4 different ways to ask the same question. Okay? Where is the 0? Where is the solution? Where is the factor? What is an x-intercept? The factor is actually the opposite of where the 0 is. But going back here, okay, I'll go back in a second. But all of these things are zeros, right? All of these things are x-intercepts. All of these things are solutions to that function. Okay? Going forward, x minus a is a factor. Okay? How much time again? 10 minutes? Not too much more time to talk, but I do. There's some lecturing here to do. Should I pause? Are we good? No? How about now? Now? Okay. Okay? Okay. I'm going to post these, so what's next? Find all real zeros. Oh my goodness. Okay? So if you have to find all real zeros, really what you have to do is factor it. And you've done this you did this on your last test more or less. If I were to, where's this tool? I want this tool. Okay? If I were going to find all the zeros of this function, I would set this thing equal to 0. What comes out of all of these? What can I pull out of x cubed, x squared, and x? X. So I could factor this to x times x squared minus x minus 2 equals 0. And then I could factor this part. Who can tell me what this part factors to? X minus 2 times x plus 1. And since these things are factors, then you kind of do the zero product property, right? X equals 0, x equals 2, and x equals negative 1. Which makes my life really easy for sketching this particular polynomial, because I know I have zeros at 0, at negative 1, and then at 2. I also know the end behavior of this is what? Well, how does it start? It starts down and ends up, right? From this being a positive x cubed. So I could kind of do a rough sketch of this polynomial function without knowing too much about it other than the zeros and the end behavior. So I know that this polynomial function, if I were to graph it, is going to look something like that. I don't know how high it goes or how low it goes. I can figure that out. But I do know that it goes through those 3 points. And I know that it starts from down here and it ends uphill. So kind of cool, right? Am I going too fast? Okay. Then I'm moving on. Rolling. Where's my toy? This next thing says. So this next idea is called multiplicity. Right? For a polynomial function of factor x minus a raised to the k is greater than 1 yields a repeated 0, x equals a of multiplicity k. If k is odd, then the graph crosses the x-axis at x equals a, and if k is even, then the graph touches the x-axis but does not cross the x-axis at x equals a. For example, I think I have an example. Here's one. Okay? So so if I were going to graph this one, okay, what is the degree of this polynomial? What's the degree?
1.
The degree is 1? No, of the whole thing. If I multiply it all out, what would it be? X to the 6, right? So the degree is, this is the degree of 6. So how is it going to start and end? How is it going to start and end? Is it going to start and end like this or like this? It's going to start and end like a parabola, like a right side up parabola, because it's even and it's positive. Yes? Okay? So what this says, this is called, so what you know is that you have a zero. If I were graphing this function, which I'm going to do right now, just sketching it, okay? At positive 3, I have a 0. 1, 2, 3. And its multiplicity is 3. And this is if k is odd, then the graph crosses through at x equals a. So at 3, it's going to go through that point. Okay? This says if x is even, the graph touches the x-axis, but it does not cross the x-axis. So what is the 0 according to this? If x plus 2 is a factor, what is the 0? What's going to make that 0? Negative 2. So I know I have another 0 of multiplicity 2 and negative 2, and I know I have a 0 of multiplicity 1 at x equals what? 1, right? You guys understand how I know those are zeros? Okay? Now, since I know that if it has an even multiplicity, it bounces, okay? It bounces here, bounces off, okay? And I know it starts up. So I know here it's going to bounce off the graph. Somewhere it's going to come down and go through here, because this is an odd multiplicity, okay? And then somewhere here it's going to go through here, because that is also odd multiplicity. And it's going to start from the upside, and it's going to end from the upside. So given something like this, I wouldn't expect you to know, I mean, you could find the y-intercept, but I would expect you to be able to sketch something like that without your calculator, knowing that it starts up, it bounces here, it goes through here, because it's got odd multiplicity, and it goes through here, because it's got odd multiplicity there as well. Yes? Hi! Time to wake up.
Sorry.
It's okay. I'm not going to tell you any more stories. I think that's the end. Do you need to take more notes? You writing this down? Let me see. What's the end? Oh my gosh. Okay. Intermediate value theorem. Okay. I'm sorry, but I just worked here. If I didn't tell some of these stories, I didn't. What the intermediate value theorem says, okay, is that if you have a function, okay, and this is some point A, and this is some point B, okay, you just listen for 2 seconds, okay. If this function changes from positive to negative, what must exist between these 2 points? At some point, if f of A is positive and f of B is negative, then there has to be a 0 somewhere between those 2 points, or vice versa. If this one is negative and f of B is positive, then there has to be a 0. For instance, okay, between negative 2 and negative 1 and this function, if I take negative 2 and plug it in here, f of negative 2 is negative 8 plus 4 plus 1, I think that makes negative 3, okay? And f of negative 1 makes negative 1 plus 1 plus 1 gives me out 1, okay? So for this particular function, between negative 2, I get out negative 3, and at negative 1, I get out positive 1. Then between those two, between this x value and this x value, somewhere in between these two, this thing must have a 0, okay? Must have a root or a 0 or a solution. That's what the intermediate value theorem says. If my function changes sign between 2 x values, okay? Sorry I had to talk so much. Homework is on the web. I'll check